Assalamualaikum. We are from Group 6, Session 3, Solid Mechanic 2. The topic we choose is a buckling analysis of a motorcycle start stand. Okay, now I want to introduce my group member. The first one is me, Muhammad Haikal bin Abdul Wahab. The second one is Haizat Brook. The third one is Akmal Amin. And the last one is Leong Tak Weng. Now I want to talk about introduction. Okay, introduction. Buckling occurs when a slender structure, like a motorcycle side stand, suddenly bends under compression, not because the material failed, but due to the shape instability. This is a common parking stand atop a small, critically support the bike weight and can buckle on the uneven ground if too weak. Our analysis use Wheeler buckling theory to evaluate the hollow steel stand fixed at the bike free at the ground contact, calculating the maximum safe load before the bending, and comparing the steel strength to ensure the real world safety, demonstrating how fundamental engineering principles apply even small everyday component. Okay, next. The objective. The first one is understand buckling in a real life structure. The project is aimed to explore how to buckling a sudden bending failure caused by compressive force affects slender structure like a motorcycle side stand. The second one is analyze the motorcycle side stand as a case study. The side stand may seem small, but it play a vital role in the keep the motorcycle stable when parked by examining how it behave under different load, especially on uneven surface. Third, apply Euler buckling theory for safety assessment. Using Euler buckling formula, we will determine the critical load at which the stand could fail. Okay, the last one is a compare practical load with the material strength. After the calculating, we will check whether it stay within the safe limit of the stand material, still yield strength, and ensure the design can handle real world force without failing unexpectedly. Okay, for the problem definition. First one, buckling represents a unique structure failure mode in which compressive force cause sudden lateral deformation in the slender elements, such as a column, beam, or strut, will entirely appearing stable. Thus, a component can experience abrupt sideway bending which is subjected to excessive load. Second, several critical factors influence buckling behavior. The first one is dimension characteristic. Second, boundary condition. And third one is material property. Okay, for the third point is a Euler buckling formula to calculate critical load. Application is primarily limited to ideal slender column under perfect condition. Design always incorporate substantial safety margin, keeping working load well below theoretical buckling limit. The last one is the study of the buckling remaining vital across all the structure engineering discipline, informing the design for everything from architectural column to aerospace component.
Assalamualaikum and good morning and good evening. So I am Akmal Amin bin Abdul Raub and I'm going to continue about the literature review. So for the literature review, I have list out all the formula that will be used in this group project. So the main formula is Euler formula. Euler formula is to find the maximum load that can be hold by a column, slender column, before it buckles. So in this formula there is a moment of inertia. So we can find three main formula in the internet for moment of inertia, which is the first one is for solid circular road, the second is for hollow circular road, and the third one is for rectangular section. So which is we will use the hollow circular road for our group project for the motorcycle stand. And then in the Euler formula also we will find the stiffness, which is K. So there is four types of K, amount of K that have in our lecture slide that we have been teach. So we will use the fixed and free ends. Okay. Okay, and now for the safety factor formula is for consider a safety margin. It is for determine the safe load that a column or structure can support without buckling. And then this lastly is the yield stress. Yield stress formula is for determine whether stress will cause a structure to permanently bend before it buckles. Okay, that's it for me. Thank you.
Hi, I am Isaac Puruprepa for the mathematically modeling part related to the motorcycle side stand. First, let's go through the assumption used in this model. The side stand is modeled as a hollow sealed tube. The boundary condition is fixed-free, fixed at the base, free at the top. The load is assumed to act vertically and centrally. The material is considered elastic and isotropic. And lastly, the silhouette of the stand is ignored in the calculation. Now on to the limitation of the model. In real-world conditions, the load may not be perfectly axial. We did not consider vibration, surface unevenness, or fatigue effect. The actual boundary conditions might not be exactly fixed-free, and the material imperfectly, like residual stress or welding defect, were not included. This assumption helps simplify the model, but the limitation reminds us the real-life result may be differ slightly from the theoretical analysis. Now let's look at the calculation and application of Euler buckling theory in the mathematically modeling part. The stand is treated as a fixed free column, and the formula used here are the Euler formula, moment of inertia of a hollow tube, and the cross-section area formula, where E is equal to 200 gigapascal, K is equal to 2, L length is equal to 0.35 meter, the outer diameter of the stand is 0.022 meter and the inner diameter is 0.018 meter, and the value we got for the moment of inertia of a hollow tube is 6.346 10 power of negative 9. Next, using the Euler formula, we got value for PCR is 35.564 kilonewton. This is the critical load, which is the load that would cause the stand to buckle under ideal condition. And also the value for the cross-section area is 1.257 times 10 power of negative 4. For the result, the side stand must be checked whether the stand is safe or not. First, using the safe load formula and apply a factor of safety of 3 to the critical load, and got the value of P safe is 8.52 kilonewton. This means that under ideal condition, the stand can safely support up to 8.52 kilonewton without buckling. Next, using the buckling stress to check whether it will yield or buckle first. And value got is 203.38 megapascal. The yield strength of mild steel is about 250 megapascal. Since the buckling stress is less than the yield strength, the stand will buckle before it yield, and the use of Euler theorem is valid in this case. So overall, the side stand is considered safe, and the analysis confirmed that it can handle the load of the motorcycle without failure under normal conditions.
Without any hesitation, let us go through to the discussion part. In our experiment, several challenges will face turns the buckling analysis of the motorcycle side stems. Uh, for the first problem is to simplify the assertions, reduce the their limbs. Um, this is because we are just idealize the structure of the modularized side stand as the perfect stretch. This assumption is mathematical modeling but limited to the actuals. For the second one is the left of the experimental validations. Since we don't have the access to experiments set up such as the universal testers mechanism UTMs to verify the buckling of the motorcycle systems, this is will slightly difference of the real world performance and the value may be different with the actuals. Third, the motorcycle system is subjected to the non-axis. So that the modeling only assists static rock does not capture the complexity of the practical users conditions, like terrain slots or lateral force during the mounting and dismounting. For the last is the negress of fatigues and vibration effects. Since we are assumes the motorcycle system stone uh, is long-term integrities under the repeating stress circles. So this could if influence the result. So we are assumes to do the improvement to increase the assurances. For the first problem, we can apply the finite element analysis, which is FEA, to model the real world complexity, including the imperfections and verify loading condition, so that we can match the assumptions easily. For the second problem, we can build a simple manual test by using the weights, puller, and mechanical supports to approximate SX loadings and observe the point of visible buckling. For the third problems, we can redesign the stem to include the reinforcements or secondary supports that help carry side roads so that it is more easily balanced to motorcycle. For the last problems, for the last problem, we can do the maintenance of side stands after a specific user cycles or time interval. By doing the Buckley analysis of the motorcycle system, we realized that across a wide range of real-world engineering problems, Buckley principles have broad significance in both design and safety critical applications. For the first one is stability analysis is lengthen structure. Undoubtedly, for the Euler buckling theory is a fundamental concept in mechanical and civil engineering. This concept is not just limited to side stands, but it is critical in the design of the structural columns and beams in building and branch or aircraft landing gear and the rocket sleds. Next is the importance of the factor of safety in design. This is show how the engineer must account for the uncertainties such as the variations in material properties, unexpected routing conditions, imperfections, and user misuse or against of components. This principle is universal applied across the engineering fields including the automotive, aerospace, marines, and structural design. It mentioned the risk to reductions and fail-safe design. For the last one is the elastic versus the plastic behavior of the material. The comparisons between critical buckling stress and material yield stress introduce yield strength introduce the concept of elastic versus plastic failure. This is important for material solutions for different loading conditions. In many systems, such as a bright pressure versus suspensions components, is preferable the Fielding Occupston Gradum plucking rather than the Sutton Sutton Fletcher. Oftentimes for interversions of rock reduction. That's all for the discussion part. Thank you.
So for the conclusion, I would say that we successfully apply the Euler buckling theory to analyze the structural stability of a motorcycle side stand. So we can see that a very small part in the motorcycle, which is a side stand, is also need to be calculated appropriately. So we can see that this chapter, which is buckling of a slender column, is widely used in our daily life. So as a engineer, we should be remember or things that this important knowledge is a golden knowledge for us that we will be used in future project or learning course. Okay, that's it for our group project. I will want to thank you very much to Doctor, because give us an opportunity for doing our group project. Thank you.